In this example, we are going to go through two different summation types of problems. This one we're going to do a summation from 1 to 20 of this. So the idea would be we'd be plugging 1 in, getting a value, plugging 2 in, getting a value, plugging 3 in, getting a value, and adding all those values together. Luckily, there are some shortcuts to this. And so we have a formula for this that when you have a quadratic piece, as long as we go from 1 to some value, then we can use this formula for it instead of doing all the individual things. And then we have a constant, or we have a k. We'll have to deal with the 2 that's on here because there's not a 2 on this formula. And then this -3 is just a constant. And so we would have a -3, a -3, a -3. We'd have 20 of them. And so we'll have to figure out how to deal with that. So first thing is we're going to manipulate it so then we can use some formulas. So we'll start by going k equals 1 to 20 of the quadratic piece, plus we're going to break off this piece, so then it's going to be 2 times the summation of k equals 1 to 20, right? So anytime you have a constant, you really can just pull it in front. That takes care of it. Now I have this exact look that I want, so then I can use the formula. And then minus this constant of 3. So there's going to be 20 of them. So a minus the 3, minus the 3, minus the 3. So we have a formula for that as well. So let's start using the formula. Get everything set up. So if we're doing the k² one, we're going to have our n value is 20. So we're looking at a 20 times 20 plus 1 times a 2 times 20 plus 1. And that whole thing is divided by 6 plus 2 times 20 times 20 plus 1 divided by 2, and then minus 3 times how many of them? So minus 3 times 20. All right, so we have our formulas. Now we can kind of go through the math on here. All right, so we're looking at a 20 times 21 times 41 divided by 6 plus 2 times 20 times 21 divided by 2 minus 60. All right, so if we start simplifying this, we got a 21 and we have a 6. I can cut a 3 out of both of those. So that'll be a 7, that'll be a 2. I could take a 2 out of the 20. So that's looking at a 10 and a 1. So the denominator's gone. Here I can take a 2 out of those two. So now it's really just 20 times 21 and then minus 60. So if I do 7 times 41, I get 287. And I'll add a 0 to multiply by 10. And then here I got 20 times 2, which is 20 times 21. So 2 times 21 is 42. Add my 0, multiply by 10, and then subtract 60. So I'm really taking 2870 plus 420 minus 60. So let's do 2870 plus, if I take 420 minus 60, that's 360. And if I add 360 to 2870, I would get a total of 3,230, right? Because we'd have a 0 and a 0. This would be 13, here the 1, we'd have 14. Here we'd have an 11, which would make it a 12, here the 1. So we would get 3230 on that summation. So I purposely try to do this by hand because most of the time, the idea is you're taking something that seems very formula or very calculator driven, and we're trying to turn this into something that we can do by hand within reason. This one, we don't have any formulas that involve trig values. So we just have to kind of plug in 0 and go all the way up to plugging in 10, right? So we're going to have a little bit of work, but well, we'll see. So if we start plugging in a value here, we're going to be starting off with plugging in 0. If I plug in 0, this whole thing becomes 0. So we're looking at cosine of 0 plus, if I plug in 1, we're getting a cosine of 1 pi over 2. So cosine of pi over 2. Plus, if I plug in a 2, that makes 2 pi over 2, which is pi, cosine of pi. Plus, if I plug in 3, then I'm going to get a 3 pi over 2. So cosine of 3 pi over 2. There's definitely a pattern happening. So 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 would just be cosine of 2 pi. Plus, so let me leave some space, plus cosine of 5 pi over 2 plus 6 pi over 2, which is 3 pi, cosine of 3 pi, which is 6 pi over 2, plus cosine of 7 pi over 2, plus cosine of 8 pi over 2, 4 pi, plus cosine 9 pi over 2. We're getting there. Our last value is going to be 10, which is cosine of 5 pi. All right, seems like a lot, but cosine graphs repeat themselves. So here's my main graph. That value is a pi over 2. This is pi. This is a 3 pi over 2. Let me make this bigger. So 1, 2, 3, 4. So a cosine graph hits these points, and then it repeats itself over and over and over and over again. So this is pi over 2. This is pi, 3 pi over 2, 2 pi, and then it would repeat itself and start to do the exact same thing. So, all right, so there's our cosine graph. So if I do cosine of 0, I get 1 plus cosine of pi over 2 is 0 plus cosine of pi is -1 plus 0 plus 1. And then it just starts all over again. 5 pi over 2 would be equivalent to pi over 2. So that would be plus 0, right? So plus -1 plus 0 plus 1 plus back to 0 again. And then 5 pi would be back to -1. All right, so those are the values that we have. So we have a 1 and a -1 undo each other, a 1 and a -1 undo each other, and a 1 and a -1 undo each other. So the summation of all those values ends up just being 0. And that was a couple different types of examples here. This one has a formula because of the fact that we have just a square, a quadratic, and a linear kind of a piece to it. But trig values don't have that, so we actually kind of have to go through all the individual values and add them all together.